as well. So the recording has started. Um, so this is made, this talk is made possible by ACM, you all know. So ACM is you all know, you're all probably members of ACM as well, but I just wanted to mention this to you. The best thing I like about ACM is that, of course, it has several members, um, and it is the premier global community of computing professionals and students with nearly 100,000 members in more than 170 countries, interacting with more than 2 million computing professionals worldwide. And the big thing I like about ACM is that it's the sponsor of the Turing Award. Turing Award is something like the um, Nobel Prize for computers. So it sponsors that. And the conferences, ACM conferences are very reputed. Um, the focus of ACM as compared to IEEE is more on science aspects, more the pure science aspects of computers. So that's another reason I like ACM a lot, because it goes to the roots. So that's about ACM. And about me. I have a lot of experience in both academia and industry. I teach machine learning and data science related courses at San Jose State University. And I also work full time currently with Infosys, managing a project for Verizon. Um, but before that, I worked for a long time with Cisco and Synopsys, Amdocs, and other companies. So with Cisco, Synopsys, Amdocs, and Infosys, I've been doing project management, DevSecOps, tool development, and support, general support. Before that, I was working on platform engineering at Informix. Now it's part of IBM. Informix was a reputed databases company that time. So now it's part of IBM. And I started my career in OS internals, operating system internals, writing device drivers, firmware, and compiler development back in India. I have a bachelor's in computer science and engineering, MBA in finance from India, master's and PhD in computer engineering from San Jose State University and Santa Clara University, respectively. So please feel free to ask me. I mean, the format is very general, like I mentioned. You're free to ask me any question anytime. Just put it in the chat window, or you can just unmute yourself and ask a question. Feel free to interrupt me. I want to keep this very interactive. So that's the reason why I listed all these topics, so that you can ask me questions in case you have any questions in these areas. So yeah, let us keep this very interactive. Students have repeatedly told me that the best part of the class is when they interact with me. So interact, don't miss on the interaction part. Hopefully, whatever I talk will generate curiosity. That's number one. And second thing is, it's when it is question and answer format, we can ensure that uh, the audience learns based on what they already know. I call it delta learning. So the learning happens in deltas, right? So we start with what you know, and then we build upon the knowledge. So that's the reason, that is the second reason why I insist on this question and answer format. And so if I just keep on talking, uh, there may be gaps, and it may be difficult for you to follow and things like that. So we'll keep this interactive. By the way, some of the topics are taken from this book. The topics that I'm going to talk today are taken from this book, which I edited, one of the recent um, books that was published. Tools and techniques for software development in large organizations. The book is available in many libraries. So you can feel free to borrow it from your library or buy it or whatever. It's available on Amazon and things like that. So there's a question on the chat window. When did you start coding? So, um, ours was the first batch of computer science and engineering students in the institution where I studied. But to answer your question directly, I started coding probably when I was in school, probably in the high school, I would think, if my memory goes right. There was one of my father's colleague bought a computer, and it had BASIC. I don't know if you have even heard that language. There was a language called BASIC. It's a beginner's language. So I learned BASIC when I was in high school, doing a little bit of programming on that computer. Whenever I would go to my father's colleague's home, I would take that computer. I think it was interestingly a Mac, if I remember correctly, uh, or some such computer. It was looking like a Mac now, and based on what I recollect, um, Mac in those days used to look a little different. So I think it was a Mac. So that's when I got to code. Um, Hope that answers. What's the minimum amount of employees considered for a large organization in terms of context of this talk? Yes, so that is my next slide. So I want to just give you a peek into a large organization. I don't want to name the organization, but I just want to give some details about a typical organization. Um, so this organization was incorporated in 1984 and went to IPO. That is, everyone knows what IPO is, right? Initial public offering. So it went to IPO in 1990. 6 years after it was founded, it went public. So that means the public were able to buy shares of this company. Till 1990, all the shares were held by um, the founders and some private parties. So in 1990, the shares were sold to the public. And this corporation has around 83 business units, and its revenue is 52 billion, probably more than the GDP of some countries. Right? Countries have abundant resources and millions of people. And this organization has around 76,000 employees globally. And with just 76,000 employees, it is able to achieve a revenue of something that is more than the GDP of some countries with several times the population. So any guesses how that is possible? So that is the power of technology, right? Technology has that power. Um, so this organization has 35% of its employees working in engineering, just to give you an idea. 25% of the employees work in sales and 40% in support functions. And its go-to-market strategy is via 300,000 partners. So it has partners. It doesn't, for instance, how do you capture market in a new country? So the best way is to partner with a company that's already flourishing in that country, and then sell your products through that company. Like for instance, IBM was present in India long back in the 70s, but it made a comeback in the 90s, I believe. Yeah, 90s, through a company called. There was a company that was formed with IBM, but the owners of the company were Tatas, the Tata family. They IBM tied up with Tata family to start their operations back again in India in the 90s. For various government reasons, they were not present in between the 70s and the 90s, and in the 80s particularly, they were not present, but they came back in the 90s. So, partners really help in your market strategy. So this organization has 300,000 partners as part of its go-to-market strategy. And the 10,000th patent was awarded to this company 7 years back. And within a short time, it generated 10,000 more patents. So I think this slide is slightly old. The data is slightly old, maybe about 2 or 3 years old, I think. So within a span of 5 years, they generated 10,000 more patents. Any idea why? I mean, they took how many years? 84 to 2014, say. So that is like 30 years. 30 years to get 10,000 patents. And then just 5 years to get the next 10,000 patents. The reason is because of the technology, right? The innovation that happens at the cutting edge. It has exponentially grown in the recent past. So this company I was awarded 10,000 more patents in just 5 years. So it's like exponential growth of innovation. And the company has $100 billion US dollars worth of assets across 165 countries. And in terms of research and development, 6 billion plus has been spent on research and development in a mode what is called as internal startups. So the company has several teams which function like startups. The culture will be like in a startup, highly paced um, and very dynamic. So they are like kind of silos in terms of the culture, and their idea, the goal of these internal startups is to innovate. So that kind of gives you a peek into what a large organization looks like. And I'm not talking about, when I talk about this organization, it's not Google, it's not one of those FANG companies, like, the acronym FANG, right? Facebook, Amazon, Apple, Netflix, and Google. They are called FANG. So it's none of those. This is a different organization, and so this is a brief profile of that organization. So there's a message on the chat. Is the 35% mostly software engineers or other kinds as well? So yes, most of it is software, but there is also some hardware involved. But hardware is not that big these days, right? I mean, manufacturing is offshore most of the time. The hardware manufacturing is all offshore. So most of the companies have transformed themselves into software companies. Even though they started as predominantly a hardware company, a lot of companies have transformed themselves into software companies. So yes, most of the 35% are software engineers. In fact, most of the employees are software engineers, because even in sales, the folks working in the sales typically start as software engineers. So for instance, the CEO of Cisco, for instance, he is basically a sales person, right? He started as a programmer as well. He was a software engineer, and he started as a programmer, and then moved to sales, and he made big in sales. So sales is also comprised of a lot of software engineers. So in that sense, most of even the 40% support functions, quite a few of them would be software engineers as well. So the organizations typically are mostly software. High-tech organizations today are mostly software organizations, run by software engineers mostly. So that brings us to the next slide. So what are some of the organizations or teams in a in a large software organization? So first is the product management. So whether there is, and the first thing that you need to have in a company is product management, right? You need to be able to market your product. So product management is marketing your product. So the team basically works on marketing the product. It has multiple functions. Marketing the product, coming up with the requirements for the next release of the product, and interacting with the market, determining the sales, the business model, kind of in a strategic business model to some extent. So all these are functions of product management, and um, a lot of these product managers are originally software engineers as well. Um, and the next is program management. Program management is basically managing the releases, managing the programs. A program typically comprises of a number of projects. The difference between program management and project management is project is a single project, whereas program is a set of projects. And it's an ongoing thing. Program is typically ongoing. So program management basically deals with, this is a new concept, by the way. I think this was invented in this century. It's not too old. I think it was, if I remember correctly, program management came into existence in 2010, I believe, when Microsoft came up with this concept. But program management is understood differently in different organizations. Like, for instance, in Microsoft, program management in Microsoft is mostly product strategy. Whereas program management in other organizations is basically managing the program. So making sure that the project is completed as planned, and removing any bottlenecks, making sure that everything is smooth with the program is the job of the program management. So next is, of course, the design and development, which probably will interest you most, because you will probably start as a developer, most likely, developing code and products. Um, you may not get into design right away, but certainly developers role is open to freshers. Um, so typically what's done in the developer's role is you are assigned some bugs. So typically the developer starts by fixing bugs. So that's how you make inroads into the code. You understand the code, and you start realizing the various components of the code and things like that. So the first task that is typically given to a fresher from college is fixing bugs. If the student is, I mean, if the student is starting as a developer. So that is design and development, and then engineering. So this engineering department is software engineering, basically. So a lot of process related stuff, tooling, and all these things are part of the engineering um, part of the organization. Then quality assurance, the testing team. So this team is responsible for testing the product that's already developed, um, and being developed also. I mean, these days testing happens along with development. I mean, it's called test driven development, right? So you write the test and then develop the code. That's the approach taken these days. So back in about a century, I mean, about a decade or two back, the testing would happen after the product is completely developed. But these days, the testing happens almost simultaneously. So we'll talk more about that, hopefully, if we have time. And so the next team is tech pubs and other operations, technical publications, so documentation. When the product is built, you need to come up with the documentation. So there's a whole set of mostly engineers again, but not necessarily engineers who understand the product and write documentation for that product. So that's operations and tech pubs. Then sales and channels, so the salespersons. Um, so the closer, one thing that I noticed over all these years of my experience in the industry is that the closer you are to the product, the higher your chances of growth. You look at the CEOs of most companies. I just talked about the CEO of Cisco. You take the CEOs of other companies as well. Cisco CEO was basically in sales. Microsoft CEO was a product manager, right? So the closer you are to the product and the customers, that's where the money is, right? The money is all with the customers. So the closer you are to the product and the field, the higher your chances of growth in the industry. That's of course we need to be really good, because customer, I mean, when you're interacting with the customers, the company's reputation is involved. So it's so these guys have to be really smart. So it kind of justifies their growth. And general marketing, so um, they kind of, I mean, marketing is loosely coined. It's there everywhere. I mean, everyone needs to be conversant with the marketing strategies, right? Even the developers need to be conversant with the marketing strategy, because we should always be having the customer in mind. So marketing is spread everywhere. But yeah, some companies have a separate department for, I mean, separate business, I mean, organization for marketing. And then training. You need to train the customers on the products that you are selling. So there's an extensive training department as well. And then customer service. This customer service is called by different names in different organizations. So it's sometimes called advocacy, customer advocacy. And there's also an escalation team in some companies. This escalation team deals with escalations from the customers. So a customer is very unhappy, escalated it all the way to CEO. It becomes a huge escalation, and this team basically works in a firefighting mode. The escalation team, they make sure that uh, uh, things do not, I mean, the customer satisfaction is utmost, right? Very important. So they make sure that the satisfaction, customer satisfaction is always, the goodwill is always there with the company. So that's the escalation team. Then the environment and tools team. So there is a separate tools team sometimes in large organizations, which is responsible for the tooling. So they build the tools that are required for productivity, keeping the productivity of the developers high, for instance. So there's a tools department. And then the infrastructure team, the IT team. So um, so they are responsible for provisioning the hardware, provisioning the applications, and things like that. That's the IT team. And then there are several other support functions, which are some of them are not even technical. Okay, there's a question on the chat. We are seeing a slight shift from customer services to customer experience, which involves what you're mentioning, customer satisfaction. Yeah, that's right. Customer experience is picking up heat in most of the organizations. There's a separate team for customer experience these days. It's very well funded, and they have a very specific charter to make sure that the customers are happy. Um, yeah, so the whole organization is all about customers. All the functions, irrespective of whether it is design and development, or whether it is infrastructure team, we should have the customer at the top of our mind, always in an organization. So so that's an important thing. Okay, let's move on to the trends, some of the trends, technology trends. Now So this is one of the requests that was made to me um, to cover this topic. So, so the first trend, industry trend, is cloud. These days, it's all about cloud, cloud, cloud. Does anyone know what cloud is? Any organization today, whether it's small, startup, or big, they're using cloud. So you can please feel free to unmute yourself and speak. Uh, because I do not want to talk about something that you're not fully conversant, right? If I assume certain things, uh, sorry,
So cloud as in like non-local data storage
yes,
or resource use, whatever.
exactly. So anything that is non-local, any computing that is non-local can be roughly thought of as cloud, right? So it could be software. So for instance, you take Google Docs. You can compose documents, you can compose spreadsheets, you can compose presentations using Google Docs, or for that matter, these days, Microsoft also has come up with a similar concept. So where you can uh, come up with presentations using the web version of the PowerPoint. So that is an example of cloud. And this is a specific paradigm of cloud called software as a service. So in cloud, you can offer a lot of things as service, a lot of things that are remote as service. So you can offer software as service, like in this example of Google Docs, where you can open a document online and start writing the document, and the computing happens somewhere in the Google cloud, basically somewhere remote from your home, for instance. So that is cloud. So cloud has a lot of paradigms: software as service, infrastructure as service. That means infrastructure means the hardware, basically, the bare metal. You can provision bare metal from a remote provider like Amazon. Amazon. So there are three big players in the cloud market, right? Today, there's Amazon, AWS, there's Google, uh, GCP, Google Cloud, and then there is Microsoft called Azure. So those are the three major players in the cloud. So you should probably try this because they give the initial usage is free. I think they give you $300 worth of credits when you sign up. So you can try various things that these clouds provide, AWS or GCP or Azure. So cloud is the top trend. I see it as a top trend today. Cloud made a lot of sense. I mean, why do you have to have remote machines in the remote using remote access? The reason is, um, for instance, you are starting a company, you need resources, and you grow very quickly. When you start a company, you expect to grow very quickly, right? If you start with a small desktop, you will run out of the resources very quickly, right? So if you borrow the same resource from the cloud, it might work out cheaper also in the long run. But the most important advantage you get is that you can scale very quickly using infrastructure as a service. You buy certain specification of hardware today, and a month down the road, you buy double or triple that software hardware configuration from the same cloud provider. So you can scale very quickly. So that is one of the biggest advantages of cloud. So that is the reason why most of the startups start with cloud. But these days, even the big companies are very much into cloud. The cloud is kind of inevitable and omnipresent everywhere in the software industry today. So certainly get experience in cloud. And then virtualization. So what is virtualization? So virtualization is basically uh, making things virtual. Like it is kind of related to the cloud concept. So virtualization is basically you specify even the software, like the operating system that you want. You specify the hardware, you specify the software that you want. You specify like I need 10 terabytes of storage, this many um, processors. You specify all those things, and then you say that you want Red Hat Linux of this version, say 8.0 or something, and then you are provisioned with a machine um, which runs the specific operating system, which is Red Hat Linux, with the configuration that you asked for, 10 terabytes of disk and 16 gigabytes of RAM and all that stuff. So you can spin up machines on the fly. So that is virtualization. So it's not a real machine. So there is no machine with just 10 terabytes of disk and four processors and whatever configuration that you have asked. It's a huge cluster of machines, and you are just using a portion of that cluster by using this concept called virtualization. So these days, in any company, any software company, the machines are virtual. Back about a decade or two ago, you would get the company would buy machines for you, like a desktop. Like when I was working in Informix 2 decades back, I was given a Solaris machine. Which was sitting on my desk. So that's no longer the case today. The virtual machines are created on the fly, and you can access the virtual machine from your laptop. You just log in SSH to that machine, and using it, you can use it. I believe you must have used virtualization in your schools also, right? The the computing resources that typically the colleges and the schools provide is basically virtualized as well. So I'm pretty sure you would have used it, but you may not be knowing that it's virtualization, in case you did not know. So next trend is microservices. So what is anyone knows the concept of microservices? Okay, there's a question on the chat window. Are there any drawbacks to using virtualization? So, I mean, virtualization, there are, I mean, there are pluses and minuses with everything, but there are no really impeding drawbacks with virtualization. You are pretty much using the machine as if it's sitting on your desktop, on your desk, kind of like a desktop. Um, so yeah, that is probably the reason why most of the companies are going virtual. Um, okay, so microservices is putting many big tools into smaller functions. That's right. So traditionally, software development used to happen as a monolith. So you develop a software that encompasses all the functionality, envisaged functionality of the product. Um, so that's how the software was developed originally. But there are many disadvantages of that software, right? For instance, um, you take the example of this controller and access points. You know the concept of controller and access points, right? You go to a mall, or say Macy's. It has 3 floors of stores in the mall. All the 3 floors will give you the same SSID, Wi-Fi SSID, right? So that is ensured by, although there are like hundreds of access points, the same SSID is there across all the 3 floors. So that is ensured by what is called as a controller. So if you are developing a controller, um, you write software for that controller. So if you develop it as a monolith, if you have to push any upgrade, if you suppose there is a bug found and you fix that bug, and now you want to push that fix to the production, that is the Macy's field, the mall. So you will have to probably bring down the whole setup. You will have to bring down the controller. You'll have to bring down the access points, shut down everything, put this new software in it, and then um, reboot the whole thing. So there's a downtime involved. But with microservices, you can develop product in as microservices, basically as small services, small functions. So each functional module of, say, the controller software becomes a small microservice. So if the bug is found in one microservice, you don't have to bring down the whole thing. You just have to push the fix, probably even remotely also. You just have to push the fix, and then the patch happens automatically. And that's how the Windows laptop gets patched these days. Right? Most of the software today gets patched automatically. You don't have to bring down the machine or the setup. So microservices is kind of present everywhere today. Any product that you take is being developed using this microservices architecture. Okay, there's another question on the chat window. So kind of be thought can it kind of be thought as an analogous to a Java interface, an isolated piece of software that can then be integrated into whatever you want? Yeah, sort of. I mean, it has to be logical also. It has to be a logical function. The other thing with microservices is that they're all loosely coupled. There's no tight coupling. So you cannot have one service depend heavily on the other service. So they have to be modular enough to function pretty much autonomously, right? So that's how microservices are developed. And so with microservices comes the concept of containerization. So what is containerization? Did anyone hear about containers? So containers are basically small, you can think of them as small operating systems. Like you have Linux running on your laptop, for instance, or you have your OS X running on Mac laptops, for instance, right? So you have a bunch of dependencies for something to run. So you try to download some software. It says that, for instance, you try to download uh, what was that? What did I download recently? So typically, okay, I don't remember the exact name of the software that I downloaded, but typically on a Mac, the if you try to download a software, it fails, saying that Xtools is not installed, right? So it requires Xtools to be installed on your laptop. So there are some dependencies like this between software components, so software packages. So container basically contains all the software that is needed for a particular program to run. Most often the program is your microservice. So typically a microservice runs inside a container. A container is like an operating system like the OS X or Linux with all the components required for the program to run, for this microservice to run. So it can be created very easily, just one command. So there's a popular tool called Docker, which is a containerization tool. So you just run Docker followed by run, followed by an image name. It spins up a container for you. So it's a small version of operating system, which has everything that is needed for the microservice to run. So as you can imagine, each microservices sits in a container typically. So there could be as many containers as there are microservices. And it happens very quickly. These are very lightweight. So this is kind of analogous to virtualization, right? We talked about virtual machines. So these containers are kind of like virtual machines, but only thing is containers are much, much more lightweight. So they're very quick to create, very quick to, we can very easily delete them also. Whereas with virtual machines, there is some process involved. There are some differences between virtual machines and containers. I just want to kindle your curiosity, basically. You can go back and read up more on these topics. But I just want to give you a brief about the kind of trends that are happening in the industry. So containerization is a very big trend that's happening, which is kind of brought about by these concepts of virtualization and microservices. So along with containerization, there is a need for orchestration. Suppose there are, say, 100 containers running 100 microservices. So you'll have to keep track of which containers are functioning properly, which containers have gone down for various reasons, and which containers are uh, need more resources and things like that. So all that you cannot obviously keep track of it manually, right? So there needs to be a software for doing all that. So the software that is responsible for the orchestration of containers is called the orchestration software. An example of orchestration software is Kubernetes, a solution provided by Google. It's one of the most popular orchestration softwares today, Kubernetes. It basically manages the containers, orchestrates the containers. The next important trend in the industry is NoSQL. So what is NoSQL? Anyone? Okay, so NoSQL, you all know what SQL is, right? SQL.
I think it's like a database thing.
Yes, it is a database concept. So you all know what SQL is. SQL stands for Standard Query Language. It's a query language to query the databases. So you have a table, like you have a name, you have the student ID, you have the courses that the student has enrolled, the grade that the student got in that course, and things like that, right? Those are, it's like a table with multiple columns. Name is one column, a student ID is the other column, and so on. So that is a database. A table is basically a database, right? So you have this SQL, standard query language, to query the table and get data from the table, right? With NoSQL, it doesn't stand for not SQL. It stands for not only SQL. So it is more than SQL. It provides more functionality than just querying the database. Now, in a typical RDBMS that you study in your college course, probably, um, you study about relational databases. So the table that I described is basically a relation. In the database terminology, it is basically a relation. In NoSQL, we go beyond the concept of a table. A table needs to have a particular format, right? Like you need to have some columns, and all the rows in the table should follow those columns. So you cannot have um, one row for the employee of the college and one row for the student of the college in a table, right? Because you have a course ID, the grade obtained in the course, and things like that. Employees will not have those fields, those columns, right? So, but in real world, it is quite common that we want to build databases which have both, which are general for students and employees, for instance. So in such cases, NoSQL comes in handy. It scales very well. Number one, in NoSQL databases, you store the data typically in form of key value pairs. So you have a key and then a value. So name is a key and the value could be John Smith, right? So key value pairs. And there's no format, no specific schema or format for these name value pairs. You can have any name, any pair, any value, any key, any value. So you could have, for employees, you could have manager's name as the key and the actual name as the value. So you can combine both student data with employee data and things like that. So it is much more general. So as if you know about normalization, you might be a bit concerned that NoSQL does not follow normalization, which is intentional kind of. NoSQL is meant for reads. So typically there is this new trend of, which goes along with NoSQL called CQRS, command query responsibility separation. So typically what is being done is today is for writing, they use relational databases. And for reading, the same data is stored in NoSQL so that the reads are faster. Because typically there are many more number of reads than writes, right? So for writes, they use uh, relational databases, and for the reads, they use NoSQL. That is called as the CRQS, uh, uh, CQRS, command query responsibility separation. So you're separating the command, which is typically an update or create or those kind of operations, from the query, which is basically a read operation. Those two responsibilities are separated into two different databases. So that is the concept of NoSQL. That is another industry trend. So by the way, is there any hard time that I need to stop, hard stop for the time? So so just let me know whenever you feel like I'll stop. I have a lot of stuff to cover. Um, so please feel free to stop me anytime. So that is NoSQL. And the next trend is languages. These languages are getting invented. Also, you learn Python, you try to master Python, and now you have to master Go language in no time. So languages have, and this trend has been there throughout my career. I started with C, then C++, then Java, then oh my God, so many languages. So this is a growing area, programming languages. So these days the Go language is very popular. It is based on the C language concepts. Um, but before that, Python is still used for a lot of stuff. And then there was R. R is also still there for the data science related concepts. So language is the other area which is very trendy in the software industry. And the next thing I thought I would talk about is the REST API. So what is REST API? What is an API first thing? Does anyone know what API is? So API is basically a call, like your function call. You all know functions, I believe, right? Application programming interface. So that is how you interact with an application. So by calls, making calls. So REST API is a stateless protocol. It stands for state transfer, representational state transfer. That's what REST stands for. But it's a stateless protocol wherein you transfer the state. So the client or the server need not keep track of the state. The state is transferred. Um, so what is client and server? You all know this cloud computing, right? There is always a server. There's a client. So there are now client has to talk to the server for various reasons. So REST API is the standard way today for the microservices to talk to each other. If the microservices need to talk to each other, exchange information, they make a REST API call. So it's like a function call. It's not too different. So there's a message on the chat window. Do you have any tips to quickly adapt to new languages you might not have much experience with? So most of the programming languages are very similar. You wouldn't take, see, I still remember the basic language, I hardly took a week. I mean, I was a high school student. You all know this, right? I mean, yeah, I should not be telling you this, but picking up languages is very simple. There's hardly any delta improvement. That is why I don't teach Python. Although most of the students in San Jose State University, undergrad students particularly, most of their coursework is done using C++. So Python is relatively new, but when I teach data science, I will have to ask them to learn Python. So I don't teach Python. I give them Python. They learn by themselves. So the logic behind that is that learning a language is not too difficult, particularly languages like Python. In Python, everything is an object. So you can do lot of conceivable things with Python. You just think about it, you should be able to do it in Python. So the programming languages are becoming simpler and simpler, easier and easier to use. So there are a lot of functionality is getting built into these languages. Like Python, for instance, machine learning program, for instance, in Python is just, you can write a machine learning program in like 7 to 8 lines. You can do wonders in Python in just 7 to 8 lines. So a lot of built-in features are coming up with the language, and they are very intuitive. So learning languages is not a big deal at all. This is probably one of the easiest of the trends in the software industry. That's what I think. Though it's it's hard to catch up because um, you establish your comfort zone in one language, and then you'll have to move to a new language. That is a bit uncomforting, but once you jump into the new language, it's again creating a comfort zone, will not take too long.
So going about that, just follow that up real quick. Going about the actual learning of it, would you just say like jump in head first, just start messing around with it and trying to figure things out, look stuff up online, and just kind of go with the flow?
Exactly. In fact, that is the approach you should take for everything. Do not wait till you are completely expert in every aspect of the thing. Like you take Python, for instance. You don't have to know a lot about Python to feel confident, just to write the first program. Learn a little bit of Python, exercise your knowledge using a few lines of code, and then you will feel comfortable. So it's a delta learning process. Always learn in deltas. Do not wait to know the whole thing. And that's the whole idea of microservices, right? You build in deltas. So learning also should happen in deltas. Good question. Okay, we were talking about the REST API. So the reason REST API is so important is, one reason is because the microservices use REST API to communicate between each other. That's one thing. And the REST APIs typically use language. It's not really a language. It's very intuitive again. A lot of software is becoming very intuitive. So there is something called YAML or JSON. You would have heard about these languages, right? YAML and JSON. YAML is a very intuitive notation. It's like key value pairs. Yeah, YAML and JSON. So these are very simple. I mean, any layman can also read these files, YAML files and JSON files, and figure out what's going on. So they are basically key value pairs. So the information that is exchanged using REST APIs is typically in the form of YAML files or JSON files. So it's very easy to come up to speed. So there was a trend previously. There was HTML. You all know HTML. Then there was a move towards XML to make the markup languages more readable, right? So XML was much more readable than HTML. So based on XML, there was what is called as a SOAP, SOAP, format for exchanging messages across microservices for that matter, or web services. SOAP was more popular with web services. Yeah, YML and YAML, they mean the same. SOAP was more popular with web services, but there were some disadvantages with web services. Web services are firstly somewhat tightly coupled. So microservices, we want the services to be loosely coupled. There should not be too much dependence between two microservices. So that's when came the REST API. So instead of exchanging XML like in the SOAP format, we microservices exchange YAML and JSON files using REST API. And the other reason I brought up REST API is for to explain a very interesting concept. So typically, any company, not just software companies, but even banks, for instance, Citibank, they they give access to a lot of their information using REST APIs. So you just search in Google, you type the company name followed by developer API. 3 words: company name, developer API, like Citibank, developer API, Cisco, developer API, Uber, developer API. Just those 3 words. And you will see the list of information that these companies so will this be distributed later? I will try to post the video unless there are some objections from anyone in the audience. I will try to post this video on YouTube. Yeah, let us see. The plan is that I will be able to post it on YouTube. Okay, so REST API. Can't listen fully, but will appreciate listening and coming back later with questions. Yeah, sure. I will provide you my. You can. I'm there on the internet, LinkedIn, Facebook. You connect with me. Follow me on Twitter. You can send messages and we can interact. We can certainly keep in touch even after this class, even after this session. So yeah, I was talking about REST APIs. REST APIs are used to access the information that the companies provide publicly. So Uber provides some information, Cisco provides some information, Citibank provides some information. For all that, they provide the information by way of REST APIs. So that is the other reason why REST APIs are so important. So certainly read up about REST APIs. Okay, so that is about, okay, I will probably wind up in a few more minutes. So the next important trend to catch up with is security. So security is very important these days. You all know the kind of hacks that are going on, and people are all the time trying to come up with ways to hack information, to do all malicious things. So that is the reason why security, cryptography are very important. So I know a lot of colleges offer a course in cryptography, so I would strongly urge you to take those courses. So security is very important. I mean, I talked about DevSecOps, right, in the previous slide when I introduced my background. So DevSecOps is the concept of integrating security with both development and operations. So that means previously the focus was mainly development and operations. But the trend is to bring security into every aspect of development and operations. So that's why it's called DevSecOps, development, security, and operations. So security is very important these days. And then for this generation, for our generation, see, when I was starting my undergrad, I was in a dilemma whether to take hardware or software. So my uncle, who was working in Australia, he was visiting India at that time. He said, for your generation, software, just blindly take software, computer science. I believed him, and it worked out very well for me. So my prediction for this generation is that it's all going to be AI ML everywhere. I mean, machine learning is playing the same role that electricity played a century back, right? Electricity, wherever there was modernization, there was electricity's role. Similarly, wherever there's modernization today, there's machine learning. So it's all going to be machine learning and artificial intelligence. So this is a very big trend. Current trend is to use machine learning for natural language processing, another area of artificial intelligence. So use deep learning for natural language processing. So all that is really catching up. Industry is also big on this AI and ML. So certainly AI and ML is a very big trend. And related to that is big data. All the techniques that we learn in AI and ML are made possible because of the big data phenomena, right? So big data tools and technologies like Hadoop and Spark, all those tools and tool sets. So that's all big data, which you need to be really catch up with. And then the process itself. A decade back or 2 decades back, it was waterfall model, what is called as a waterfall model. So there would be development, followed by testing, then followed by development and things like that. So there were stages. Um, but these days, software development happens in small chunks. So that is the agile way of doing software. So this agile. So when I give project, the students in my classes do a course project towards the end of the course, they present the project as well. So I insist on practicing agile, even for projects. For their course project, academic projects, I ask them to follow agile methodology because that will give them a practice into practice of what is practiced in industry. So agile is the big thing. It has come to stay. And then configuration management is basically uh, a set of tools which handle configuration of the environment for you. So there are tools like Ansible and things like that. Instead of writing detailed scripts each time to manage the configuration of machines, like each machine needs to, like we talked about in containerization, we saw how there are dependencies between software packages and making sure that the containers are properly configured. So all that is handled by config management tools, configuration management tools. So that is the other trend in industries, usage of configuration management. Then of course, networks. Network is there. I mean, network trends are really needed to understand a lot of cloud related stuff, a lot of virtualization. I mean, it will help if you have background in computer networks, it will help understand a lot of other concepts. And then the field of networking itself is growing. I mean, there's 5G, there's multiple aspects of networks. So networks is the other important thing. And then tools. There's a whole bunch of tools. I wanted to quickly show you something. Okay, let me see if I'm done with this. And then the DevSecOps that I talked about, right? Development, security, and operations. So these are two important things that are growing really rapidly. Tools and the number of tools and the DevSecOps area. Development, security, and operations. They all work together. So I just wanted to give you a glimpse of the tools that are currently available for various things, for various software operations today. So you would have recognized this. This looks like a periodic table in chemistry, right? So they came up with this company called Zabbia Labs, came up with the periodic table for the tools that are used in software engineering, DevOps, development and operations. So they neatly categorized. So the orange ones are the various kinds of databases that are available, the tools for databases. The blue ones are continuous integration. So all these tools are continuous integration tools. So, so you can search, this is available, I'm pretty sure this is still available. You search for periodic table for DevOps tools and you will get this. Okay, so that's about the DevOps. And I wanted to quickly cover on your academic preparation. I will not take a whole lot of time. So I insist, um, in my classes that students be very comfortable with math, because computer science is basically applied math, right? It's so you have to be very comfortable with math. You need not know everything in math, but at least the thought of math should not scare the student. So math is very important if you want to stay in computer science. Then analytical skills. Computing itself is analytical, so analytical skills are very, very important. And programming. When I go to India every year, and the students there ask me, are there any jobs which do not involve programming in software? I have to disappoint them. I mean, everyone starts as a programmer. There are no jobs if you don't understand programming. So programming is also important. And teamwork. Software industry is all about teamwork. It's very, very important. So practice teamwork, hard work. I mean, we talked about cloud, right? Software as a service, infrastructure as a service, platform as a service, and all that. So I call software engineers life as a service as well. LAAS, life as a service. Our life is basically a service to others. If you want to be a software engineer, we have to be at the cutting edge all the time. We have to keep on learning. And so hard work is very important. Then the courses, data structures. See, when I was a student, I did not know that data structures play such a big role. You even if you have done PhD, data structures still has a big role. So that is the reason why I instituted a gold medal for the toppers in data structures course in my alma mater back in India. So then algorithms. Algorithms are very important. And like we talked, languages are propping up like mushrooms. So you have to be abreast with languages and data. Uh, when you talk about data science, databases are really important. So databases, cryptography and security. I'm pretty sure most of the colleges have cryptography and security. So certainly take that course. Uh, it's a bit analytical, but you'll really appreciate it if you have the analytical bent of mind. And like I mentioned, artificial intelligence and machine learning is going to be the key driver of economy in the future. So certainly focus on AI, ML, big data, and the process itself. Software engineering is all about process. So learn agile, think about process, networking will always be there. Everything runs on a network, right? Your internet itself runs on network. And then tools. There's an explosion of tools. The market is being flooded with tools. So coming up to speed with tools is important. And then certainly target for internship. Try to get industry experience. It is very important. Internship is very important. And then of course operating system. About 2 or 3 decades back, operating system would have been the first concept of academic preparation, I would think. But now it has taken a slightly backseat, but not that back, because the whole idea of distributed systems is kind of dependent on your understanding of operating systems. So operating systems also is important. And so how do you prepare for the job market? Brush up on your algorithms, data structures, pair programming. Practice pair programming. In industry, that's a very common trend. Pair programming is basically two programmers sitting together. One would be programming and the other would be watching and correcting the mistakes and things like that. So pair programming. So in my course projects, I ask my students to practice pair programming, and in the rubric, I have a criteria for pair programming also. I grade for pair programming and practice agile. And then system design. One of the biggest chunk of interviews lies in system design. For instance, how do you design a system which generates or shortens a URL? You have a long URL. How do you generate a shorter URL? That is one problem. Another problem is, how do you design the system for, say, an Instagram application? So broad level architecture, like the boxes, you should be able to draw the boxes, explain what's in the box, and things like that. So system design is important. And then of course languages, then tools, certifications. for instance, cloud may not be taught in your coursework in the college. So that is where certifications come in very handy. So take some do some certifications, like AWS has a certification, Kubernetes has a certification. So certainly do certifications. That builds the credibility. And then networking. So uh, have a network of people in the industry. So for instance, you can connect with a lot of people on LinkedIn. Like I am open to connecting with the people in my audience in the talks that I give. I make this open. You feel free to send me a LinkedIn invite. I accept it. So network, improve your networking skills, attend meetings, try to talk to people, and then build your brand. So what I do for my courses is I ask my students to uh, generate a video, come up with a video explaining, giving a elevator pitch, giving an elevator pitch of the project that they worked on during the course. So that really helps in building their brand. When the recruiter searches for you on your name, this video might come up, and then the good work that you did for the project will also come up. So building your brand is very important. So leverage the social media, social media. Then build your credibility in a number of ways. Make sure that at least whenever you go for internships, make sure that your supervisor is very happy with you. That's how you build credibility, because the word spreads very quickly, right? So you can probably get some recommendations on the LinkedIn and stuff like that if you do a good job with your internship. And resume is a great tool. Don't underestimate resume. Often I see resumes in a very bland format. It has to be really striking, not only in format, but also in content. So make sure that your resume is a great tool, and then practice mock interviews. There are some meetups. You can form mock interviews within your school itself. Um, and then industry watch. Keep an eye on the industry. So you can search for, again, 3 keywords: zip recruiter, and the area that you're interested in. For instance, DevOps is an area in software industry. So that area followed by keywords. So zip recruiter, DevOps, keywords. Just search that in Google. It will give you a set of skills that are expected for this role in DevOps. So keep a tab on the industry trends always. And then you build a profile of projects. Do really solid projects in your courses. I always insist on this. So do projects so that you can write them in your resume and build your credibility. And then culture aspect is very important these days. You may be really solid, good, but if you don't fit the culture of the company, then they don't like it. They may not, the chance are, so behavioral interview questions are very important. You should be genuine in them, in answering them. So you have to genuinely develop that culture. The common trait across the industry is teamwork. So teamwork, rank it really high. And then debugging. So when I interview candidates, I mainly test on analytical skills. I mean, I don't even test for whether they know the tools, whether they know the languages that we are using and things like that. I test for their analytical skills and their debugging skills. Because if these are there, learning any tool, any language is not that big a deal. And some URLs, I don't know if I'll have time to go through. I wanted to actually show you this. So the first URL is ZipRecruiter, is a website for hiring, and the field that you're interested in, and then followed by the keywords. So this, okay, I'll show you anyway, since so I clicked on that link, and you can see this is what comes up. So you click on this, it will show you the skills that are needed, and the top skills mentioned in the resumes, engineer skills, skills listed by the employees. So all that is there. So the first link is really important. Then linkedin.com is also a great tool. You can leverage LinkedIn. Sorry. Okay, anyway, LinkedIn. So LinkedIn has many okay. So LinkedIn has many features which will help you build your brand. For instance, this is my page, and I can show you very quickly. You look at the profile. So have a solid headline first. It should be really attractive. And then you can feature some of the things, some of your achievements in your courses right at the beginning. So you can feature as many of them as possible. And then you can have features for each role that you, for instance, you did internship and then you have a solid email from your supervisor saying that you did a great job. You take permission from your supervisor whether you can put it on LinkedIn, and then, or if you have received a certificate from the company where you interned. So you should be able to put your certificate right there on LinkedIn. So that's how you build your profile. And then the recommendations. Try to get as many recommendations as possible. So, and then the skills and endorsement is another area where you can list your skills and ask your connections to recommend, what is it called? Endorse. And then you can have recommendations. Uh, don't go for any recommendation. The recommendation should be really strong. So that is also important. Few recommendations, but they should be really strong. For instance, the very first recommendation on mine reads, Vishnu is one of the best customers I have worked with. So something like this will really add a value to your resume, to your brand. So build your brand. And then the next thing I wanted to show is, one second. Why does this happen? Okay. Anyway, it is not allowing me to click. I'm kind of running out of time. So, so there are other URLs. For instance, there's a website for practicing algorithms. It's called LeetCode. A lot of interview questions actually come from LeetCode. Okay, it is now come up. So this is the LeetCode website. So the problems are neatly organized as easy problems. So difficulty, frequency, acceptance. So difficulty, you can choose an easy problem to start with, then go for medium. So these are all algorithm problems. And for some of these problems, the solution is already provided. So LeetCode is a great resource to practice interview questions. Then HackerRank. HackerRank is the other website. So HackerRank is the other website, which is similar to LeetCode. You can solve algorithm, and you can come up with algorithms. Then interview questions. This educative.io is really good for interview questions, coding, behavioral, and so on. And then there are a lot of meetup groups just to talk about interview skills, where you can practice mock-up interviews and things like that. So leverage these groups. There are several groups. You can see these are all the locations where the groups are listed. So certainly leverage this. And then GitHub. GitHub has a lot of code. Okay, that's fine, I think. So GitHub has a lot of code, and particularly the style guides. Every company has a coding style guide. So just go through the coding style guide for various companies. And YouTube has lots and lots. You all must have already been watching some videos, but YouTube has some really great videos. So watch those videos as well. Udemy, a lot of good courses, industry specific courses like microservices. There are a number of courses. Cloud computing, there are a number of courses. Particularly if you want to prepare for certification, there are very good courses, industry related courses in Udemy. So leverage them. And then Gartner is a company which does this trending. It gives you, I'm particularly interested in what is called as the hype cycle. Gartner comes up with a chart called the Gartner's hype cycle every year. So it lists out all the trending technologies for that year. It predicts what all technologies will be in trending for that year. So that's a great resource as well. So those are some of the useful links. I think we are almost on time. So let me see if there are any questions. Uh, any tips for landing internships? Something that employers might like to see essentials. So a lot of my students, I mean, I teach data science courses anyway, but a lot of my students, undergrad students, tell me that they they land up internships in data science related areas, particularly. So you may want to really be strong in data science for internship roles. But yeah, internships can be like a student who interned with me from I think he was from Purdue, if I remember correctly. So I gave him a long back, of course. I gave him a DevOps kind of role. I asked him to build a tool, kind of help me build a tool. So it all depends on the requirements. But data science has better chances for internships in terms of technology. But nothing beats networking. I mean, if you have contacts in a company, uh, that really helps. Somebody who knows you in a company. So that's how you leverage the networking to gain internships.
Vishnu, several of the people here are community college students, so they'll be finishing perhaps their second year. Do you have any suggestions for internships? Are there internships available at that level?
Oh yes, there are multiple internships. I'm pretty sure you just have to keep an eye for them, and uh, yeah, and typically, yeah, networking really helps. So you go to for instance, there was a talk. In fact, I also attended the talk, and a bunch of students also came for the talk, and the students met that speaker after the talk. They started describing their own background. I mean, they were like second or third year students, I believe. And they explained their background. They said that they are doing these projects as part of the course and all that stuff. And the speaker was impressed, and he kind of asked them to submit their resume. And one of the students told me that he got a internship based on that talk, attending the talk. So yeah, networking really helps. Face-to-face interaction really helps. Okay,
Thank you.
sure. So there's one more question, I believe. As someone with a background in CSC, to what extent does familiarity with the workings of hardware and/or engineering concepts help with writing and optimizing code? So writing code is basically an analytical task. That's how I would put it. So engineering is also an analytical task. So certainly there's a lot of transfer learning. In artificial intelligence, it's called transfer learning. The knowledge that you gain from engineering, other fields of engineering, can be easily transferred to coding because it's all analytical skills. So it certainly helps if you're already conversant with the engineering aspects of some other field. But certainly computer science and engineering is growing at a very rapid pace compared to all other fields of engineering. Like compare with civil engineering, for instance, traffic engineering. How much has it grown in the last few years, last few decades for that matter? And compare it with the growth in computer science. 3 decades back, artificial intelligence was really peak. I was a student that time. And so so there was a computer that was being built in IITs. I mean, IIT is one of the premier institutions in India, and it was a nodal center for artificial intelligence. There were, I think, 5 or 6 branches of artificial intelligence those days, and each branch had a nodal center in India. So this was a nodal center for speech recognition, I believe. And so those days, that computer used to take 24 hours to just recognize a word like hello. To recognize the word, it was taking 24 hours. And these days, Alexa, you give commands to Alexa, and it interprets them in microseconds. So that is the kind of expanse that we are experiencing in software. So yeah, certainly the skills that are needed for software are much more superior, but certainly it helps if you have background in other areas, other engineering areas. I got a full-time offer for a cloud infrastructure team. So want to know if there are any extra tips on making sure I am up to date on staying on top of putting myself forward, especially in a big company. So that's a great offer because cloud is there everywhere today. You take a small company, big company, any company, cloud is there. So certainly that's a great, so congratulations first of all on landing that internship. Oh, full-time offer, that's even great. And how to stay on top of things. Yeah, basically you have to look for trends, keep on looking for trends. These links really help you a lot. So you network with someone in this area on LinkedIn, for instance, and that person posts something on cloud. So that's how you know that that's what is trending. So follow some of the people on LinkedIn, experts on LinkedIn, subject matter experts may not be accepting connections. So in such cases, you just follow them. But some like I told you, I am open to accepting. You just mentioned that you attended this talk in the invite, and I'll accept your connection. Right. So some are open like that. Some are not very open. So following them, if they are not open to connecting, at least follow them on LinkedIn, on Twitter, on various social media channels. So that is one of the best ways because you know the trends more than these sites. You know the trends can be known through word of mouth, and the word of mouth in today's generation is social media. So following Twitter, following LinkedIn, that's how you, following someone on LinkedIn. So that's how you come to know of the trends. Okay.
Well, thank you. Folks, I don't know if you guys have any more questions, but if not, thank you. Is it Dr. Pendyala? Am I pronouncing it correctly?
Yes, that's the
Okay.
right pronunciation.
Thank you to Dr. Pendyala. It was very useful hearing about all the software trends, and these links are going to be wonderful for the students. And I can't agree with you more about networking. I just wish it were easier to do that, but you have some good suggestions. Folks, Dr. Pendyala, as he mentioned, teaches machine learning. And I noticed that you also give a talk on machine learning. Is that correct? An ACM talk? Yes. So, you know, if you guys are interested in that kind of thing, we could certainly invite him back for a topic of that kind, because as he says, machine learning in the AI world is going to be a big thing, or is a big thing today. So we want to thank you, Dr. Pendyala. Very informative. We appreciate the time you've given us. In another world, we would ask you to stay for coffee and something, but you know, today's world doesn't exactly allow for that. So thank you very much.
Sure, it was a pleasure. Thank you.
You're welcome.
Okay,